Good morning. Let's go through the homework questions that you had on Monday. So question 7 should have been really straightforward because we've done exactly this question in the notes. Now normally cubic functions won't be injective because a horizontal line will usually cut it more than once. And an injective function must either never be cut or be cut at most once. So if we look here though, the graph of the function y equals x cubed is a special case, and any horizontal line that we try and draw through this will only ever cut my graph exactly once. And of course, the x-axis is our special case where we're going to look and see if we've got multiple roots, and we don't. It only cuts it once at 0, 0. So this is an injective function because it doesn't cut it more than once. It's also a surjective function because there's nowhere where it won't cut it. So in fact, it's a bijective function, as we noticed in our notes. So we've used the horizontal line test. Is this enough? Is this enough of an answer? No, we really do need to write down our reasoning here. So it's injective. No horizontal line cuts it more than once. Cuts f of x more than once. And it's also surjective because every horizontal line cuts it at least once. Cuts it at least once. Okay, you may have given your explanation a little bit differently to that, but we do need to put down some kind of explanation. Of course, because it's both, it's also bijective, but we weren't asked that, so we don't need to write it down. So that's what we need to do for question 7. Question 9. We're shown the graph of a quadratic function here, mapping the real numbers onto the real numbers. Is it an injective function? Well, is there any horizontal line that can cut this more than once? Yeah, in fact, the x-axis, this line here, y equals 0, will cut it twice. So it's not an injective, no, because the line y equals 0 cuts the graph twice. Why does that make it not injective? Well, it means that there are two different inputs, two different x values that will give you the same output. Okay, that's what this means. When x is equal to 1 or when x is equal to 3, both of those give the same output. And there are other values that this is true for as well. They both give the same output of y equal to 0. The roots are the easiest ones to look at. Is it a surjective function? Well, we could draw a horizontal line up here that doesn't cut the graph at all. But let's just check here. Is it a surjective function in the range, in the outputs of y less than or equal to 2? Now, so if I don't draw any horizontal line that's bigger than 2, will it always cut the graph? Yes. So it is surjective in this range. But not if y was greater than 2. Okay, so a better explanation then, we just write down our reason. So any horizontal line that has y less than or equal to 2 will cut the graph at least once. So it's surjective in that range. Could we put a restriction on the domain? So remember, domain is my inputs, the x values, to make g of x an injective function. So could I do something here to this graph that would mean that any horizontal line would never cut my graph more than once? Well, yeah, if we cut it in half. So it's only after it's curved around that we start to cut it twice. So if I said that x was less than or equal to 2, no horizontal line will cut more than once. And that would make my function injective. It's not so useful though, is it? It's not really a quadratic anymore if we do that. But we can put a restriction on the inputs whereby it's going to be an injective function so long as the x values are less than or equal to 2. Also, if the x values were greater than or equal to 2, but never less, so you could also do this side. So either strictly bigger than 2 or strictly smaller than 2 or equal to 2. So that's how we, that's how we can restrict either the outputs to make it surjective or the inputs to make it injective. Right, question 10. Use a horizontal line test to investigate if this is injective. So straight away we can see it's not injective because I can draw a horizontal line through y equals 3. So the line y equals 3 cuts the graph 1, 2, 3 times. So therefore it is not injective. But is it surjective? It is. There is nowhere we can draw a line that won't intersect that graph at least once. So it is surjective because any horizontal line will cut the graph, intersect with the graph at least once. Okay, no matter how far down here I come, there's always going to be a tail here that will cut the graph. No matter how far up here I go, there's always going to be a tail up this way where I'll cut the graph. So it is surjective. Is it bijective? No, because it needs to be both injective and surjective to be bijective. So let me just write that down as the last part here. It's not bijective because it's not injective. And you don't need to give more of an explanation than that. You can if you want. You could say, and it needs to be both injective and surjective in order to be bijective. But just saying that it's not injective, so it can't be bijective, and that is sufficient. Okay, so that's our horizontal line test with graphs of functions to check if they are injective, surjective, and bijective.